and that is portfolio theory. Now, we need to understand our learning objectives. Why are we learning this particular topic? Or at the end of this topic, we are supposed to be able to achieve something. So, our learning objectives include several items that I have for you. The first one is you should be able to explain what risk and return is. You should also be able to calculate risk and return under different conditions. And in finance, we have condition of certainty, where you know the situations or the outcomes of each condition, and condition of uncertainty, where the future is uncertain and you have to incorporate some issues or probabilities. Then you should be able to calculate risk and return for single securities. So this is our first section, and at the end of that first section, we should be able to handle some of the illustration questions, and also as a class, we can have group discussion or attempt the assignment questions. The second part of this topic is portfolios. Here, we've seen that the first part, we should be able to calculate risk and return for single securities. So portfolios is a combination of securities. We could have two or more securities. So we will have a case of two risky assets or two risky securities, and the second one is a case of a risky asset and one risk-free asset. Then, once we are able to calculate risk and return for portfolios, we should be able to come up with a portfolio opportunity set curve. This curve will enable us to ascertain which is the optimal security that an investor can actually attain. Then we should be able to explain implication of portfolio theory in finance. Now, we should have assignment questions at both sections. So you can see we clearly have part 1, risk and return for single or individual securities, and part 2, risk and returns for portfolios. Now, let us start with the first part 1, risk and return. Now, we cannot be able to calculate until we are able to define what risk is and what is return. Any idea what risk is? I wish to give an opportunity to one or two people to answer. In layman terms, what risk is and what is return? Okay, fair enough. We go ahead. Let's start with the first part. What is risk? We've seen the different definitions of risk, and from financial perspective, risk is defined as variability. Now, variability comes from the word variance. And in another word, we can actually say variance is the deviation. Now, when you expect something, when you expect a return, sometimes it's not something that you actually get. So anything that deviates you from achieving your objectives is what is referred to as variance or the deviation. Now, risk can be measured by variance and standard deviation. Now, the first one, variance, is the difference between the actual experience. Most of the time we have what we call a target and the actual. So the deviation between these two is what is referred to as the variance. Now, the second part is the standard deviation. Standard deviation is still a measure of deviation, but it looks at how far the numbers or the expected deviates from the mean. So you could have an average, and how far are you from the average performance, either of returns or of any item that you're looking at. So we have two items there that measures risk in finance: variance and standard deviation. I hope that is clear. Now, we say we are going to look at risk under two conditions: condition of certainty and condition of uncertainty. Now, under condition of certainty, basically what you expect, the expectation can be derived because you know the outcome, you know the situation or the possible outcomes under different conditions. In finance or in economics or in any economy, we could have different situations. We could have an economy or a situation where the economy is experiencing growth, or it is under normal condition, or it is under recession. Now, when we talk about condition of certainty, we know basically under situation of growth, what are we going to achieve? We already know. That is why variance is given simply by that particular formula where we have sigma squared equals to summation of return, the actual return, minus the expected return squared divided by n. So under condition of certainty, that is how we calculate variance. Our focus will be mainly on condition of uncertainty because the future is uncertain. So our main objective will be the second part where we need to attach probabilities. So when the probability distribution of expected returns is measured or expected, then we have variance being given as the summation of all the probabilities under different economic situations or under different expected outcomes, looking at the deviations squared. Now, that is the formula for calculating variance. For standard deviation, basically, we are looking at the root of the variance. So, the summation of PIs, the probabilities, we know for sure probabilities add up to 1. So, at different economic situations or different economic conditions, all probabilities should be able to add up to 1.0. Now, the summation of PIs are deviations of the means squared. Now, that is the first part. The second part is return. We were able to define what return is. And return can simply be explained as capital gain or appreciation of the value of investment. Now, what you have today as an asset, if it appreciates, that means you are able to gain. You are able to get a return from that particular asset. Now, different assets receives or we are able to get different capital gains or returns. Some assets appreciate in value, but at the same time, they give you what we call cash flows during the tenure of that particular asset. So if you are holding, let's say, an asset like a property or a building, and we are going to see an example under condition of certainty and condition of uncertainty. So return basically is measured as a percentage. The formula is simply given as return equals to price at the end. You can say price P1 minus PO, price at the beginning, plus all the cash flows received, divided by the price at the beginning, multiplied by 100. Remember, return is calculated or it is measured in percentage. Now, that means under condition of certainty, we know the price of an asset at the beginning, we know what we are going to sell or dispose or salvage at the end of the period, and all the relevant amount of cash flows or benefits, financial benefits that we are going to receive. So we should be able to generate all this information, we should be able to generate a return. Now, it is possible to generate a return under condition of certainty because we know the outcome. If you have an asset which is worth $1 million today, you purchase this asset and it's going to generate. So this basically will be our price at the beginning. PO is given as $1 million. Then price at the end, if we are to sell this property, if it is something or an asset that depreciates, like if you have a taxi or a van, public or private van, then it means it will depreciate with time. So the price at the end, P1, should be less than this after we depreciate the asset. Then let's say we are going to sell it at $500, $500,000. Remember this asset, if we are holding it for 2 or 3 years, it should be generating some values to us. So it should generate what we call financial benefit. So if per year we are getting $500,000, then times 3, that is $1.5 million. So we should be able to calculate return under condition of certainty, whereby at the end of the period we are disposing the asset at 500,000 minus, remember we are subtracting first the initial price, which was 1 million. We need to add all the benefits so that we can be able to see whether we have gained or we have lost. Allow me to wrap that. Plus 1, 5, remember this is return for 3 years. Divide by the price at the beginning, 1 million. Now, 500 plus 1.5 is 2 million, minus 1 million, that is 1 million. Okay, so we have 1 million, divide by P1, 1 million, times 100%. This is 100%, but basically it is for 3 years. So the return per year is 100 divided by 3, which is about 33.3%. So that is how we calculate. We know for sure that this asset will cost us 1 million at the beginning, and it will generate us, or it will generate for us 500,000 every year. This is condition of certainty. Anything could happen that will lead you to receive more or less than that 500,000. But for sure we know the condition, and we are also able to ascertain the disposal value or the salvage value. So that is why we are able to calculate return under condition of certainty. Now, just like risk, our main focus is return under condition of uncertainty. Now, when the future returns are uncertain, now we need to actually use probability so that we can be able to calculate returns. And for that case, then we say the average or expected mean returns is given as ER being equal to summation of all the possible outcomes that we don't know, but we want to calculate expected returns. So summation of PIs multiplied by the returns. Now, so far we have 2 main formulas that we have learned. Actually 3. If you allow me, we can write them here. The first one is variance under condition of uncertainty. And under condition of uncertainty, the formula is given as the summation of PIs multiplied by the deviation squared. And we say standard deviation is basically the root of the variance. Expected return minus minus R, minus deviation squared. Now, we have another formula for return, which is given as expected mean returns being equal to summation of PIs multiplied by their expected returns. Now, with these three formulas, 1, 2, and 3, you can actually be able to see that we need to calculate returns first so that we can be able to calculate variance under condition of uncertainty. That means we need this formula here to be able to calculate the variance and the standard deviation. So in any situation that we get ourselves into, if you are given a question to be able to calculate risk and return, the first approach is to calculate returns. Thereby, you will be able to calculate standard deviation and the variance. I hope that is clear. Now, there are assumptions in finance or in economics. There are assumptions that we need to have. Otherwise, we have everything happening at the same time. If you don't hold some certain factors constant, then all the other financial or economic factors will be working at the same time and will not be able to calculate or make financial decisions properly. Now, for this particular aspect of risk and return, we have two main assumptions. And these two main assumptions will be able to dwell on them and see how we can be able to make better investment decisions. Now, the first assumption is that all investors, me and you, all investors are assumed to prefer higher expected returns. That is obvious. We want to invest today, but we want the highest expected returns. So, if anyone invests today, he is not investing because he wants lower returns. All of us want higher expected returns to lower ones. So we don't want lower expected returns. But at the same time, we know for sure that for us to be able to get higher returns, you have to take higher risks. But investors, here we are assumed to prefer lower variance or lower risk to higher ones. And this is obvious. For you to be able to get higher returns, you should expose yourself to higher risks. But it is unfortunate. And this is how we are. And that is why I have this question. Why do we behave in such a way that we prefer higher expected returns to lower ones? But we know for us to get higher returns, we have to expose ourselves. We have to go for higher risk ventures or for higher risky investments. So the reason behind these two is only in one word: rationality. We are rational. Human beings are rational. So we will see later on how we can actually dwell on these two assumptions and see which way we can be able to make better financial or investment decisions. Now, let's look at an illustration. Now, this illustration basically will enable us see or be able to calculate risk and returns for single securities. So this is the first part. We have an illustration there, and later on we are going to see an assignment question which you will attempt. Now, the first question will calculate the expected return and risk of an asset with the following probability distribution. Now, we have different economic situations and the probabilities are given to you as well as the returns. Okay, there are different economic steps or situations of an economy. We could have rapid expansion, we could have moderate expansion, no growth at all, or moderate contraction, the opposite of expansion, rapid contraction. Now, the first step, we said, we have three formulas there. For you to be able to calculate risk and return, the first step is to calculate return, because that expected mean return will guide you or will help you to calculate the variance. You can see very clearly here that this expected return is used there and also used there. Now, the first step is to see that all probabilities are adding up to 1. Chances of anything happening is 100%. So make sure you add all the probabilities, and all these probabilities should be giving you 1.00. The returns are given there in percentage. At times they may be given in decimals. It could be 0.23, 0.18, 0.15, 0.09, 0.03. Either way, you could be able to calculate returns and risk. So let's look at this illustration. There are two approaches. There are two approaches to this. You could have it from the formula. We said the formula, the first step is to calculate expected return. So formula is given as PI RI. So we know the summation of all these economic situations, their probabilities multiplied by the expected returns. So we could have it. There are two approaches. Let me do the first approach, is the raw approach, whereby you look at 0.12 multiplied by 23% as given there, plus 0.4 times 18% plus 0.25 multiplied by 15% plus 0.25 multiplied by 15% plus 0.15 multiplied by 9% plus the last one 0.08 multiplied by 3%. Now, that is the first approach. And I would use the second approach, which I also prefer. If you do this and using your scientific calculator, you can be able to get the answer directly. But still, if you miss out on any part, then you will miss out on the answer. So the best approach is actually to have it on column, the columnar way. Now, the columnar way is, the formula is given as ER, PI multiplied by RI. So for us to be able to get the ER, you have it as a column at the end. You are given the probabilities. First situation, we can write here economic state. Economic state. The first one, 1, 2, 3, 4, 5. And the probabilities are given as 0.12, 0.40, 0.25, 0.15, 0.08. The returns are also given, and these are in percentage: 23, 18%, 15%, 9%, 3%. So it's very simple for the columnar approach. I like the column approach because you just multiply this and you get your answer there. Yes. And at the end of the calculations, you should be able to get your summation there. Summation of PIs multiplied by RI. I wish you could be able, somebody to punch for me, calculate all this, and so that we can be able to move at the same time with all the answers there.